Hey, it's me, Steve. It's August 31st, 2017. Time is 16:45, and it is 73 degrees Fahrenheit out. I'm going to pick up the roof caddy for my Jeep. Thank you, Sarah. But I'm going to talk real quick about, actually not real quick. I know this isn't going to be short. Warning! I'm going to talk about scientific mechanisms. All right? Basically, in a nutshell, scientific method is just it's a process to explain the observations and data. That's all it is. A mechanism does not need to predict anything. It does not need to have a mathematical expression, and it is not a scientific law. Mechanisms and scientific laws are also parts of theories. They are not above theories. You cannot disprove a theory by falsifying a mechanism. That's not how it works. All right? Now, there are many theories that use mechanisms to explain things that have changed through time, and theories themselves change. That's what they do. They adapt, and if the theory's entire foundation is crap, then it goes away. But I need to, before I get to examples of scientific mechanisms, and I'll sit here and cite how some have changed, and how some have stood the test of time, how some are just around because we have no better explanation of them, okay? But first I need, if you're not going to know what I'm talking about, I'm going to describe kind of like what a mechanism would be. Say I just make this theory that involves, at some point, me from getting from point A to point B, okay? And within that theory, the mechanism I derive for getting from point A to point B is me walking by putting one foot in front of the other, okay? That doesn't predict a goddamn thing, okay? It doesn't predict anything. It's just the mechanism of how I'm getting from point A to point B. Now, if that's short, that point A to point B is a short distance, I can predict how many steps that'll take and how much time that will take, but that's still not the mechanism making a prediction. That's a prediction of the theory, all right? Now, after I move point B further away, my margin of error is going to increase. I'm not going to get the number of steps right. I'm not going to get the time right, because as I'm going further away, there's a lot of variables, some of which I may be aware of, and a lot I may not be aware of, that could affect me reaching point B. But it doesn't negate my theory or my premise or my mechanism in any way, shape, or form. All right? So, okay. I hope that was clear as mud. Now, a little clearer, sorry. Still draining sinuses from that damn cold. In a week now. Okay, so what are some mechanisms that have changed within theories? Well, let's take the theory of gravity for one. All right, Newton thought gravity was a force, and that the mechanism that kept planets in orbits was the battle between centrifugal force, which wanted to shoot them out of their orbit, and gravity that would be pulling them in. That mechanism worked fine, and it's still, if you're still in everyday life, it's still usable in everyday physics. You can still use that. That mechanism is still valid. But Einstein comes along and describes gravity as not being a force at all. It's the warping of space-time. Okay, so Newton's mechanism for the explanation of gravity was incorrect. All right, it was wrong. So it changed. No big deal, right? But that mechanism between the battling of the two forces and the warping of space-time don't predict a goddamn thing, okay? They're not meant to predict. And although Newton's concept is falsified, it doesn't matter, all right? Because it's a mechanism. It doesn't negate the theory of gravity. All right, so here we go. I'm also going to talk about something people are familiar with, the KT extinction. Cretaceous Tertiary extinction. By the way, we don't use the term tertiary anymore, haven't in 5 years. 50 years ago, 60 years ago, that extinction event was well known. We had lots of different, at the time, very viable mechanisms for what initiated that extinction. And there were a lot of them. And at the time, they were all viable. Disease, competition of mammals against what they thought were just dumb reptiles. But we've learned a lot since then. All right? we've learned a lot about biology and evolution to know that none of those are really viable or true, and plus our fossil record is more complete than it was then. We have better data. And somebody came along and postulated that, well, it was an asteroid impact. Well, it's another mechanism. They had no evidence of the mechanism, no direct evidence. Well, that's not true. They had the iridium layer, so they did have evidence. All right, so I said they had that. But they didn't have the smoking gun. Well, now we have the smoking gun, the Yucatan Peninsula crater. Okay? But that asteroid impact about 65 million years ago was the mechanism that initiated the KT extinction, and it predicts nothing. It doesn't matter. See? Because it's a mechanism. It doesn't need to make a prediction. I mentioned in my previous video, plate tectonics is another example of this. We observe the plates moving about from each other. Alfred Wegener, when he first proposed his concept of continental drift, he didn't really provide a mechanism, which kind of shot himself in the foot. He sat there and provided what he thought was going on, which was totally incorrect. He thought the continents moved about over the ocean floor. Now, a mechanism he could have proposed was, ocean currents could do it. We'll just throw that in there and say that's it. But he didn't. All right. And once we started learning about mid-ocean ridges, deep ocean trenches, and could actually send things into space so we could measure continents moving, we realized that his concept of continental drift was the very basic premise that the continents move was correct. Other than that, everything else was wrong. So a new theory had to be developed. That's a theory of plate tectonics. We still are not 100% sure what drives the plates. We have several mechanisms, and a mechanism can be described in one sentence or 100 scientific papers. It doesn't matter. It's likely a combination of mechanisms, which in the natural world is usually what happens. There is almost never a single cause to something. That's an oversimplification. All right? So the mechanisms that drive plate tectonics, we have subduction caused by gravity, which is called pull slab, or slab pull. Sorry, my bad, I got it reversed. We have mantle plumes, which cause things to drift, and quite possibly and likely gravitational interactions between the Earth-Moon system and the Earth-Sun system played a very, very important factor in that. And they are all likely responsible to a degree for this stuff. Now, the exact details are still being hashed out, but those are all viable mechanisms. And what do they predict? Nothing. All right? They don't predict anything. We can't predict when a new mantle plume is going to pop up and where. We can't, or at what depth. We can't say a subducting plate through slab pull is going to subduct there for the next week, let alone 100 million years. A week is way, we know it's going to happen in a week, but for the next 100 million years, it's going to continue. We can't say these things because these are mechanisms. And if one of these mechanisms becomes falsified, it doesn't negate the theory of plate tectonics in any way, shape, or form. That's why probably one of the most praised philosophers of the 20th century, Fodor, however you pronounce his name, he did not understand scientific processes very well. He was a brilliant philosopher, I'll give him that, but his understanding of basic, I shouldn't say basic science, that's not true. His understanding of how mechanisms play a role in a theory, he had no concept of. Because that's why whenever somebody brings them up when we're talking about a scientific theory, the first thing that comes out of my mouth is, why are we bringing hobbits into this? Sorry, it's a bad joke. But anyway, because none of his arguments he's ever given against science are valid. They're easily ripped apart because his entire premise, his basic premise, his 2010 book was the one where he railed on natural selection and evolution. His premise is wrong. Okay? He tries to sit there and falsify natural selection within evolution. Therefore, evolution must be wrong. Even if you did falsify natural selection, which no one ever has, If someone has another mechanism, it's fine and it works. Evolution doesn't negate evolution in any way, shape, or form. All right. So I just wanted to hopefully there explain to you what. Sorry, my left turn signal is no longer working. That's why it's going bump, 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 instead of actually just clicking. That started this morning. But I hope that clears up for you what a scientific mechanism is and how it relates to a theory and laws, and why just negating or axing a mechanism or realizing or falsifying a mechanism doesn't falsify a theory. But anyway, that's it. Please leave comments or any questions. I hope you like so.